this problem right here is the little bit tougher problem. Okay, this is like the one we put on our notes with 5 stars yesterday. This is that one. Okay, it's a little bit harder than it needs to be, but that's why I said you can use a calculator to help us fill in the sign chart. Okay, find, or given the first derivative of g of x, find the extrema of g of x. Okay, we're finding extrema. So what do I need to do to find extrema? Set that equal to 0. This is the first derivative. I'm going to set equal to 0. Remember, extrema means maxes and mins. That is a first derivative question. All right, so all I need to do is take this thing and set it equal to 0. So x natural log of x minus 4 natural log of x is all equal to 0. Super yucky here. Okay, I need to solve that. What can I do? Take out a natural log of x. If they have something in common, I don't care if it's natural log of x. I don't care what it is. You can factor it out if they have, both of them have it in common. So I'm taking a natural log of x out. And then I'm going to be left with x minus 4. Great. Just like always, I'm taking each thing and setting it equal to 0. This one's easy. It's x is equal to 4. What about that one? Natural log of x is equal to 0. This is a math fact you need to know. And I know we're not very good with natural logs, but the answer here is 1. Okay? The answer is 1. That is something you need to know. You need to know that the natural log of 1 is 0. Okay? Let me quickly draw you a picture of that graph. This is what a natural log graph looks like. It's never negative. You can't plug in a negative number for natural log. That is a natural log graph, where the natural log of 1 is 0. Before 1, it's negative. You can't go before 0. You can't get 0 either. And after 1, it's positive. That is a concept here that would help us out. Everybody good? All right. So, Jonah's calling me back. This is G prime. No, I'm good. I'm recording a video anyways. That would be weird. There's 1. There's 4. I'm putting them on my sign chart. What's the number I can plug in between 1 and 4? 2. So I'm plugging 2 into this. What is going to happen if I take the natural log of 2? Is it positive or negative? It's positive because it's on the right side of that. Okay, if you can know your natural log graph, you're going to know that this is positive. If I plug in a 2 here, it would get me negative. Positive times a negative is a negative. Now, if you had to use your calculator, great. In the future, I wouldn't let you do that. You got to know the basic graph. It's natural log. It's not that deep. Okay, what if it was e to the x? What would that graph look like? Show me with your arm. What does e to the x look like? E to the x is this one. It's never 0. It's never negative. Okay, those would be the 2 that they would ask you. All right, cool. We got that. Number bigger than 4, so 5. The natural log of 5. Oh, it's positive. 5 minus 4, it's positive. It's positive. A number less than 1, really you can't plug in 0 or anything less than that. You really can only plug in like a half. That's what makes this a little bit weird. Again, that's why I gave you a calculator. But the natural log of 1/2 would be negative. And if I took 1/2 here, 1/2 minus 4, that would be negative. 2 negatives are going to get me a positive. Show me with your fingers which value there is going to be a maximum. Which one of those values is going to be a maximum? Tell your neighbor, why is 1 going to be a maximum? Max at x is equal to 1 because g prime of x does what, Jesse? Changes from positive to negative. That is my justification, and we're going to do that more here in the future. But if I wanted to justify, how do I know that's a maximum? It's because the derivative changes from positive to negative. Okay, the derivative means the slope, so it's changing from positive slope to negative slope. Yeah, that's definitely a max. Okay, and I'm going to have a min at x is equal to 4 because g prime changes from negative to positive. I was being super lazy there. Let me be super lazy, but make it easier to read. Control C, Control V. There we go. So 4 is a minimum because it changes, G prime changes from negative to positive, negative slope to positive slope. A little bit trickier of a question, but not really. It's the same concept. Questions are, let's take a quiz. Here we go. So looking at this quiz you just took, here are the answers. Number 1 was C. We're finding critical numbers. So to find critical numbers, we took the derivative, we set it equal to 0, and we solved it. Everything had a 3 in it, so I divided a 3 out, and I just factored. Critical number, I don't care about a sign chart, because a critical number is just when the derivative is 0 or undefined. So all I had to do was pick when it was 0. Okay, number 2, we were trying to determine what's happening. So I already had the first derivative. I set it equal to 0, and I solved. I got negative 1 and 2. Then I did a sign chart. I plugged in numbers. Again, this right here should have been a clue to you. When that factor is squared, it's not going to change signs. Okay, so it did not change signs here at negative 1. So negative 1 is not a maximum or a minimum here. It is neither. Okay, but 2 is a minimum because it changes, f prime changes from negative to positive. That's why it's C. Number 3, we're talking about decreasing and concave down. To talk about decreasing, we took the first derivative, we set it equal to 0, and we solved. We threw it on our sign chart. To find concave down, we took the second derivative, we set it equal to 0 and solved. We did a sign chart. Then I drew overlapping charts. When is it both decreasing, so f prime is negative, and concave down means the second derivative is negative? The only time that happens is between negative 2 and 1/2. Number 4, to find inflection points, I wanted to look at the second derivative. I found the second derivative. I set it equal to 0 and I solved. I got 0 and 1. I put it on the sign chart. Whenever f double prime changes signs, that's a point of inflection. So it happened at x is equal to 0 and 1. It's a little weird that it's written as an ordered pair. They got 0, 0 by taking 0 and plugging it back into the original. And they got negative 1 by taking 1 and plugging it back into the original. Last one, number 5. Let there be a polynomial function such that f of 4 is negative 1. So boom, I got my point. F prime at 4 is 0, so that means its slope is 0. And f double prime at 4 is less than 0, means it's concave down. The rest of that garbage I don't care about, because it's asking about the point 4 comma negative 1. So I only care about when x is 4, not when it's less than 4, greater than 4, or anything else. Okay, it is a maximum, because if it's concave down and your slope is 0, that's a maximum. That is the second derivative test. Questions on any of those? Did pretty well. Okay, flip it over to the back side. On the back side, you are doing a fill in the blank. A fill in the blank here of going through and answering each one of these questions. Each line is going to be only one answer in the box. Okay, so each line, as you say, critical numbers occur when blank happens. You're filling in from the box up above with your neighbor. I'm going to give you about 3 or 4 minutes. Work through that. See what you can do with it. Talk to each other. This is a good thought process. Go. So we are filling in the blanks more than anything else. This is just getting your mind in the right track. When you see this vocabulary, when they ask you a certain question, hopefully your brain will be in the right direction. Critical numbers occur where? Max H, when do critical numbers occur? That is not wrong. Okay, so that I can see why you would put it there. Because critical numbers, that's where a maximum minimum could occur. But critical numbers happen at what 2 spots? Jalen? Good. And so you're not wrong, Max. What you said made sense. But this is where we're trying to figure out, when do they happen? They happen with f prime of x is equal to 0, or when f prime of x is undefined. When the derivative is 0 or undefined, that's where a critical number could happen. Just because it's a critical number does not mean it's a max or a min. And so that's kind of the difference between the two. If we're talking about extrema, Umalati, what does extrema mean? Good. Max or mins. So if we're talking extreme, that's maximums and minimums. When do maximums and minimums happen, Cannon? Critical points and endpoints. That was kind of the first thing we talked about. Critical points and endpoints. That's where max and mins happen. Inflection points happen. When what? Emma, when do inflection points happen? When the second derivative changes signs. Wonderful. If you want to know when a function is blank or blank, we should analyze the first derivative. Michael, if we want to know the function is blank or blank, we're going to analyze the first derivative. Increasing or decreasing. That's what we're looking at. If they're asking you a question, whether it's increasing or decreasing, that is a first derivative question because it's going to tell you the slope. If you want to know when a function is blank or blank, we should analyze the second derivative. Renee, when is that going to happen? Yes, ma'am. Concave up or concave down. That is when those are second derivative questions. This one's the tougher one. A function is considered concave down when what is true? Luke? When the second derivative is negative. Definitely true. When f double prime is less than 0. What's the other one here? Yep, Lulu. F prime of x is decreasing. Remember, both of those phrases mean the same thing. The second derivative is negative or f prime is decreasing. Those are the same thing. That one's a little bit trickier, and we'll do that more later on. Let's fill in these last ones. A function is considered increasing when f prime of x is greater than 0. A function has a maximum when f prime changes from positive to negative. That's a maximum. Slope changed from positive to negative. To analyze a derivative, you find critical numbers and you create a number line. And then once you have that number line, you plug in numbers in between the critical numbers to make a sign chart to help decide what's happening. Again, kind of silly. I made it up. I get to do things like that. Okay, but then you can look through it and get a better understanding. Okay, if you're unsure on something, hopefully that clears it up maybe a little bit and it's written out for you. You have a quiz review. Okay, I gave you that today. That is due on Friday. Okay, you won't see me tomorrow, so that gives you one more day to work on it anyways.